Alright, welcome to Section 11.1, Simplifying Radicals. I just want to share something with you that I always think of when we get to this type of section. I did grow up in the 90s, and back then a pretty popular movie was Teenage Mutant Ninja Turtles. So that's just what I think of whenever I'm dealing with simplifying radicals. For some reason, I don't know, I just get stuck saying that to myself for a while. Radical, radical. I suggest, I know you kids are all into the new TMNT movie, but if you ever get a chance, go ahead and check out some of the earlier ones. They're real good movies and real exciting. So that's like I said, just a short scene from the first one when they're talking when the sensei is talking about where he found the turtles and the fact that they could talk. He thought that was pretty weird. So it's a little different plot line, but it's really exciting at the same time. So today, we're going to be talking about simplifying radicals, and we're just going to be dealing with expressions here. So to start off, the main thing that you want to think of is this prime factorization. Now, prime factorization is just the same number, so it's just the number written in product form. In fact, written in prime product form. And you're going to have a hard time seeing that. Let's zoom out a little bit. So prime product form. And really what that means is I'm going to break down a number into all of its little pieces. And each one of those pieces are going to be prime numbers. So let's talk about how to do that. And there's multiple ways to do it, but everybody has their own way. And as long as you get the same answer, technically nobody's wrong. So I always think of factor trees. I'm sure you did those a long time ago, but what numbers multiply to give me 18? Okay, well, 2 and 9 do. Okay, 2 and 9 multiply to give me 18. And 2 is a prime number, so I can stop, but 9 can be found by going 3 times 3. So really, the prime factorization of this number could be, or would be, 2 times 3 times 3. We're going to go ahead and write that as 2 times 3 squared to save a little bit of room. There will be times that we want to write them all out and keep them as 2 times 3 times 3, but we'll get to that in a little bit. Okay, let's look at the next one, 80. So to get 80, you can think of going, like I said, there's multiple ways to do it. You could go 10 times 8. All right, that would be one way. I like to just go in line and divide by the smallest possible prime number I can, because remember, 1 is not a prime number. So 80 is a multiple of 2, and it's 2 times 40. 40 is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. All right, so how many 2's do I have? 1, 2, 3, 4 2's, and 1 5. So I would write it as 2 to the 4th times 5, and you should as well. All right. Now, like I said, there's multiple ways to do these problems. Like in this one, since it ends in a 0, I would just go 10 times 36. All right. I'm not saying that either way is easier, because it's really not. If you can think of two numbers that multiply to give you your number, maybe just go with that. But I know that 10 splits up into 2 times 5, and 36 is 6 times 6. 2 and 5 are done, but each 6 is 2 times 3. Okay, but you would call that more of an even factor tree than this one here that kind of trailed off to the right. But both of them are correct, and you could definitely do this one going 360 divided by 2. Then you've got your 180, and divide that by 2, and you could keep going that way. It'd be fine, and it would work. The only problem that I have with this one is I kind of have to look around for my factors. See, in this one, they all kind of went in order. I got a bunch of 2's and then a 5. Here I've got 3 2's, but they're here, here, and here. But that's okay. So because that's all just kind of my work, my answer goes up here. So 2 to the third. And then I want to go with my 3's. I have 2 3's. So that's 3 squared and then 5. And that's my prime factorization of that number. Why don't you go ahead and pause the video and try the last 3 of those. Okay, welcome back. In this one, I'm going to start off, I know it's even, so I'm going to divide it by 2. And when I divide it by 2, I get 54. And then I know that 54 splits up into 6 and 9. 6 is 2 and 3. 9 is 3 and 3. Okay, again, I could have gone 2, and what would that be, 27? And that would work just fine. But either way, whatever floats your boat and gets the problem correct. So I have 2 2's and 3 3's. So we get 2 squared times 3 cubed. Okay. Next one, we have 315. I know that it's a multiple of 5, so I'm going to start with that. That leaves 63. 63 is 7 times 9. 9 is 3 times 3. Okay. So what we get is we get 3 squared times 5 times 7. Notice all these numbers, the reason it's called prime factorization is all the bases are all prime numbers, and the exponents can be, just however many of those prime numbers you have. Hopefully you had a little trouble with 47. It's already a prime number. So 47 is just your answer there, 47 to the first if you had to, but that's your answer in that case. All right, so let's look at what we're actually, why we're doing this, and how is doing this going to help us with what we're doing today. So radical expressions, that's just what we're going to be working with, but a radical itself, it's just the square root symbol. So it is the square root symbol. The reason they call it radical is not every root is a square root. The main ones that we're going to deal with are square roots, but it doesn't have to be. It could be a cube root or a 4th root, 5th root. Any number root is something that you can have. What that square means, for us, square means that, we need 2 of them. And we'll get to what that means in a little bit. But anyways, the radical is just any symbol that looks like a square root symbol. And I'll draw you a picture here in a second. But the radicand is the number under the radical. Radical, radical, radical. See, you got that stuck in your head now, don't you? If I have the square root of a number, see how I did that? Okay, this symbol right here, that's the radical. And the number down here is the radicand. All right? And that's as simple as it is. We're not going to be talking about that much. You might hear people say instead of, square root of a, they might say rad a or radical a. And I don't know why they do that. It's kind of an old school thing. So maybe you'll hear some older math teachers talking about it that way. And a lot of times it's, math teachers that are maybe more heavy into the math than the teaching sometimes, it seems like. But it's all the same thing. I've heard people say, rad A or rad AB or rad 57. And it's just, you just have to understand they're talking about square root. But let's look at the product property of radicals. Okay. For any real numbers a and b, the square root of a times b equals the square root of a times the square root of b. All right, and in words, you can just say the square root of the product is equal to the product of the square roots of each factor. Okay, now how we're going to use that, and really the main way that we're going to use that is to find the prime factorization and then pull out any pairs. Okay, we technically won't be using this specifically, but this is just something that's really good to know, and we're going to use it later. But the main way that we're going to do it is to find the prime factorization So I'll find the prime factorization and then pull out pairs. Okay, and if you remember, I said that there are times that we write it as like we write it with exponents, and then there's also times that we just want to write out the numbers themselves. And this is the time that we want to write out the numbers themselves. So what I do is I say, all right, 18. Did that up above. Yeah, it was 2 and 9, and 9 was 3 and 3. Okay? Some people would say, just get it to 2 and 9 and use this product property, which is okay, where you would have like square root of 2 times square root of 9, and you can figure out what the square root of 9 is. All right? You should know what it is. Maybe you do, maybe you don't. Okay? It's not a big deal. The way I do it is a little bit different from that, but it's the same idea. So what I'm saying is that the square root of 18 is equal to the square root of 2 times 3 times 3. And what I want to do is I want to cancel out a pair and bring one of those out in front. So I kind of think of this square root or this radical symbol as a trap. And you need a buddy to get out. So does the 2 have a buddy? It doesn't. This 3 does. It has that other 3 right there. So those 3s buddy themselves up and come outside, and they cancel out in there. When you and your buddy come outside of the radical symbol, you kind of morph into one, I guess. That's the way I think of it anyways. And we get root 2 as an answer. So I got my buddy, we become one person, okay? And there we go. That's what we're left with. The 2 doesn't have a buddy, it doesn't get to come out. Okay. Let's go and look at the next one. We found the prime factorization of 315 up above. I'm just going to use that. So we have 2, that's outside, square root or radical, whichever one you want to say, it doesn't matter. But it was 3 times 3 times 5 times 7. Same type of problem here, because the only thing that has a buddy, the 3's have a buddy. So they'll come out. And when they come out, they're just multiplied by what's ever there already. So 3 times 2, and then 5 times 7 is left over. Okay? Now the 5 times 7, the 5 and the 7, they don't have buddies, so they just get multiplied back together. And the 3 and 2 get multiplied together. So we get 6 square root 35. And there we go. Okay. Not too bad, right? Let's go ahead and turn the page. Oh boy. We got a bunch of stuff going on here. Okay, so we're starting with, I have that -3 out in front. That's just going to stay there. All right, nothing to really worry about there. If it comes into play later, it comes into play, and we'll deal with it then. So from here, what I like to do is I like to use my factor tree. And in fact, I'm going to need more room, so I'm not going to write it here. I'll write it down here. But I'm going to prime factorize up here my 108. Well, 108, that could be like 2 and 54. I think we actually did this one. 54 is 6 and 9. 6 is 2 and 3. And 9 is 3 and 3. So that's my prime factorization of that. Okay? And so I'm going to rewrite that. And then I have the x to the 4th, and we'll talk about that here in a second. So let's see what all has buddies. So I have 2, 2, 3, 3, 3. 2 times 2 times 3 times 3 times 3. And then I have 4 x's multiplied together. X, 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 X. All right, who all has, you think of Finding Nemo and Crush going on the I don't remember what it was called, but remember they're exiting out of the freeway like water. Do you have your exit buddy? Who has exit buddies? You've got an exit buddy. There's a pair of 2's right there. A pair of 3's right there. They have an exit buddy. A pair of X's and a pair of X's. So all those get to go. Okay, they all get to leave the trap that is the square root symbol. So outside I have my -3 that was already there. I have my 2, a 3, an x, and an x. Inside, what's left? Well, 3 is the only thing left, so square root 3. Pretty much a lonely 3 in there. Then all I want to do is I want to multiply what's left outside. 3 times 2 is 6. Sorry, that's a -3, so -3 times 2 is -6, times 3 is -18. And that'll be an x squared with a square root of 3 left over. So a little bit tougher problem C, but it's still doable. All right. Let's look at the next one, and then we'll try to help you out, and then you guys can try a few. So let's look at 189. All right, I don't want to do it below because that's where I'm going to do most of my work. So this is just kind of think space up here. So 189 is a multiple of 3, and it's 3 times 63. And I know that 63 is 7 times 9, and 9 is 3 times 3. All right, so it looks like I have 3 3s and a 7. So square root 3 times 3 times 3 times 7, 3 A's, 4 B's. And we can write them all out. We don't have to. I'll show you a trick here in a second. Okay. So who has exit buddies? A 3 has an exit buddy. A's have exit buddies. And then 2 sets of B's have exit buddies. And they're all getting off of the next exit. Okay. So what are we bringing out? We're bringing a 3, an A, and 2 B's. So B squared. What's left over? 3, 7, A. 3 times 7 is 21. A. All right, so that's my answer. Now, here's a little trick for you to deal with the variables raised to different powers. Okay. Notice I need 2 A's to pull 1 A out. Well, I only have 3, so what's 3 minus 2? That's 1, so there's 1 left over. Okay. I need 2 B's to pull 1 out. Take 2 away from 4, what am I left with? 2 more, so you can take 2 more out. Does that kind of make sense? So what you need is, if there's more than 2, you can take 1 out and leave what's left over, or any multiple of 2, and you're taking out that multiple of those. So, b to the 4th is, there's 2 b squareds there, and you need 2 b's, and yeah, it makes sense. But what you have to do is you just have to practice with it. Okay, and you should start seeing a pattern here. Over here I had x to the 4th, so 2 of them came out and none were left inside. 3 A's here, 2 of them came out, 1 left inside. Okay, or sorry, 1 came out with 1 left inside. All right, number line's kind of hard to see, but knowing perfect squares definitely helps people out quite a bit. So the square root of 4 is 2, the square root of 9 is 3. So this number line shows you a couple things. It gives you what the perfect squares you're looking for. What ones have whole numbers. If you get something like square root of 172, it'd be in here somewhere, but it doesn't have a whole number answer. There is no other whole number answer between 169 and 196. Okay? And, at the very least, I would memorize, and maybe you already have, at least up to there. Step 2 is memorizing up to 12. And then 15 it doesn't get much harder after 12, because 13 is 169 and 14 is 196. I like those because you just flip the 6 and the 9 and you get the other one. And then 15 is 225. So just some things to think about memorizing, because it does help you out. Go ahead and pause the video and try these last 4 problems. All right, here we go. Let's go ahead and look at this. I know right away that 196 is a perfect square. So I'm going to have -2. 196 is 14. So 14. And I get 2 y's out of this y to the 4th. So what am I left with? I'm only left with an x. Simplify the multiplication outside. That's -28. y squared, square root x. That's my answer. Not too bad. Okay, if you have to, you can do the prime factorization thing, but if you don't have to, you don't need to. All right, you could have prime factorized this 196, but it really would have came down to 2 2s and 2 7s. All right, to where you're pulling out a 2 and a 7. 2 times 7 is 14. All right, let's look at the next one. I have a 2 outside. That's going to hang out there. 27, that's 3 times 9, and that's 3 times 3. So maybe you get 3 times 3 times 3 times x times y times y. If you have to write it out like that, you can. Find your exit buddies and see what's left over. Okay, so we get 2 times 3 times x times y, all outside. What's left over? A sad little 3. So we get 6xy square root 3. 63 simplifies, we actually did it up above, into 7 and 9. And 9 is 3 times 3. So we should get the 5. You should pull out a 3 and 1x. And you're left with the 7, 1x, and 1y. So 5 times 3 is 15. So 15x square root 7xy. And now for the last one, 216. Oh boy. Let's go ahead and look what that is. I don't know off the top of my head, but it's a multiple of 2. And that leaves 108. That's also a multiple of 2, leaving 54. We actually did 108 right above. 54 is 6 and 9. 9 is 3 and 3. 6 is 2 and 3. So I have 3 2s and 3 3s. That's what 216 is. So I'll do this the crush way. That's what I'm going to call it. The crush way. 2 times 2 times 2 times 3 times 3 times 3. And a bunch of x's and a bunch of y's. No other way to say it but that. 1, 2, 3, 4. That's an x. And then 5 y's. 1, 2, 3, 4, 5. Who has exit buddies? Come on, Crush, help me out. There's a pair of x's, pair of x's, pair of y's, pair of y's. And what am I left with? So here we have negative 4 times 2 times 3. And 2x's, 2y's. I'm just going to write those x squared, y squared. And then square root, I have a 2, 3, and a y. So 2 times 3 times y. And then all you have to do, simplify what you got. That's going to be a negative 24, x squared, y squared, square root 6y. Hopefully you learned a little bit about simplifying radicals today. If not, if you need help with stuff, feel free to ask me. Make sure you're summarizing notes. Okay, that's something that people tend to slack off on. Remember that I am checking for that. But go ahead and get the practice and application problems done. Good luck on the mastery challenge. Let's keep going through this term. We're almost there. Keep the end in sight. Have a good day. All right, for Unit 11, we only have 3 sections, so I went ahead and decided to go with the top 3 Abbott and Costello clips. Now, this is Bud Abbott and Lou Costello. They were very popular in the 1940s to early 1950s, and really, kind of the comedy geniuses of their era. And they actually, really ended up being replaced by what would be Dean Martin and Jerry Lewis, if you've heard of those two. Another great, strong comedy team. So let's go ahead and look at a few of their clips and see what they look like. Yes, it is a little bit old, and no, I was not alive during that time, but they're still pretty funny clips. So number 3 is Horse Race. Enjoy.
This is a terrible way to get money.
Never mind that. You promised the princess a horse, and you've got to go through with it. Spill it. Stinky Fields sent us up here.
Yeah. He's a good friend of Shorty McAllister's.
Yeah, we want to see big-hearted Charlie.
Try your luck on the ponies, boys?
No, we want to play the big horses.
Well,
No. He wants to make a bet.
Okay. 1, 2, don't make any slip. 3, 4, we'll take the little drip.
Hey, wait a minute. What's this little drip business?
Just testing.
Oh, testing.
Hey, come too. Slicker's got an easy mark.
Here, pick yourself a horse.
Oh, okay. I'll pick a good one, too.
Let me look at your form.
Huh?
Let me look at your form.
Well, if you get a kick out of it, okay.
What are you doing?
You asked to look at my form, didn't you?
Nothing of the kind. Hey, you gonna bet a lot of money? How much you gonna bet? $20?
Oh, no.
$50? $100? How much you gonna bet? $1.
We don't take any dollar bets here.
Too big for you to handle? Take any part of it.
Shh. Listen, bet $10.
$10?
$10.
I bet $10.
$10, right.
Make with the coconuts.
They're off. The race is over. You lose.
Hey, come on. What kind of stuff is this?
Wait a minute.
They're off. The race is over. I lose. I didn't even bet. I don't know what I'm doing. I mean, come on, run that race over again and run it slow motion.
The man is right.
Wait a minute. You know the name of the horse you bet on?
That's got nothing to do with it. I mean,
What is the name of the horse you bet on?
well,
Well, how do you expect to win when you don't even know the name of the horse?
Man's right. Man's right. Now, this time, double up on him. Bet $20.
$20 my eye.
My eye? It's a good horse. $20 to win. My eye. They're off. The race is over. You lose.
What is this? What's coming off here?
What room are we playing in?
Now, wait a minute.
Where do we stay?
Just a...
I mean, after all, just $20 my eye. That's an expression.
Give this boy a break.
All right, now in the next race. There's only 2 horses in the race.
2 horses?
That's right.
V for victory.
Hey,
Can't
come
lose.
here. Only 2 horses.
Yeah.
Bet on both of them. You can't lose.
Bet on 2 of them.
Certainly.
Can't lose.
How can you lose?
Okay. What's the horses' names?
Jelly Bean and Lollipop.
$20 on Jelly Bean.
$20 on Jelly Bean.
$20 on Lollipop.
$20 on Lollipop. You're just in time. They're at the posts.
They're off. Lollipop takes the lead with Jelly Bean second. At the far turn, it's Lollipop and Jelly Bean. Now it's Jelly Bean and Lollipop. They're running neck and neck.
Come on, Jelly Pop.
You mean lollipop?
I mean Jelly Pop. I'm betting on the 2 of them.
Now they're rounding the turn for home. It's Lollipop by a nose with Jelly Bean closing fast.
Come on, somebody. Come on.
They're in the stretch. It's Lollipop pulling away now with Jelly Bean's jockey going to the whip, but he's pulling up now. Going to be a close finish. Now they go into the wire, and the winner, China Clipper.
Oh, boy. China Clipper. China Clipper.
Straighten this thing out.
Look. Only 2 horses in the race.
That's right.
Jelly Bean and Lollipop.
That's right.
Out of a clear sky. China Clipper. That's enough.
All right, but wait a
Quick
minute.
joint. That's enough.
Wait a minute, boys. Now in the last race.
That was my last race.
Just a minute.
Come
There's
on.
only 1 horse in the race.
I wouldn't bet if there was no horses in the race. My mother always told me never to bet horses.
How are you going to lose with 1 horse in the race?
I don't care if there was no horse in the race. What's the horse's name?
Mattress. Come on, make yourself a fortune.
Only 1 horse?
1 horse in the race. 1 horse. 1.
Put $10 on the nose.
$10 on the nose.
Put $10 on the tail.
$10 on the tail.
Here's another $10.
What for?
Put it under the saddle.
What's that for?
In case the horse comes in sideways.
Oh.
Here's where we take the rest of the bankroll.
Now I got you. There's only 1 horse in the race.
They're off in a bunch.
Go for the bunch. There's only 1 horse in the race. How can they all be off in a bunch? Only 1 horse in the race. Get the horses off the track. Hey, you! The horses, get off the track, will you?
At the half, it's Mattress and going strong.
Come on, Mattress, come on.
At 3/4, Mattress.
3/4 Mattress.
Now she's coming into the stretch. It's Mattress with only a furlong to go. She's pulling away now as Mattress comes down to the wire, and the winner, Mattress.
Oh, boy. I win. I got a winner.
Just a minute, folks. It's a photo finish.
Photo finish. How can it be a photo finish? Only 1 horse in the race.
Lollipop just came in from the last race.
Beat it, boys. It's a race.
A race? What do you mean?
Somebody take off the cuffs.
Well, he can't do this.
I think this job is going to be steady. Out the back, please. Hold all bets till we get the results of the photo finish.
You mean I still have a chance to win?
You said it. Mattress wins by a nose. Pay off the little drip, $200.
Okay. But I smell a rat.
What are you looking at me for? Shoot me. And don't forget what Barnum said about suckers. You can fool some of the people some of the time, and some of the time, most of the time, somebody's got to get it. One way or the other. And another thing, you can lead a horse to water, but you can still only go 35 miles an hour.
Come on.
Hey, Big Charlie, here's your $100 back.
What happened?
The drip got the drop on the droop. Give me back my rod. Come on, come on.
Say?
Sorry.